You bring up the better point.
I will also admit that I was like this.
Nope.
Oh my god.
Alrighty, so in case we're wondering, chapter 6, section 2, woo, more vectors. Again, the formulas that we're going to get today on the board are going to be on your formula sheet, so you can access them there, but hey, let's find out why. Okay, so dot products of vectors. Woo.
I have a quick question.
Okay, I'm ready.
What is a vector?
Oh, a vector is basically a vector.
Despicable Me. Remember him?
Never watched that, but I do know what you're talking about.
So a vector is basically a ray, okay, like when you think of what it looks like, but it doesn't necessarily act like a ray because it does actually stop. So it's not.
So it's a line?
So it's got a direction.
It's a line segment that goes in a direction.
Yes.
That's fun.
Okay. Line segment that goes in a direction. Yes, I like that. All right. But we also have our definition from yesterday, Friday's notes, if you really care. But
So it's like drawing a line.
Yeah,
goes
it
in a
is.
direction. Got
Yeah.
it. Understood.
okay, perfect. Then we're there. And you didn't miss anything. All right. So
I feel like I missed something.
yeah, I know there's more than that. Okay. So, wow, there's lots of arrows going on now. Okay. So here we are with the dot product, all right? So a dot product is very interesting, especially when you are multiplying two component form vectors. Component form just means that they have these pointy brackets instead of what we would normally think of as your rounded brackets, because those are coordinates. That is a good question. A lot of the stuff that we start to do in PreCalc, you kind of have to have like a math type
The math thing.
or the symbols. Like if you go to the symbols category. Yeah, no, insert symbol.
Yeah.
All right, that one. It's really fun. Formatting is like amazing.
You can do it on Google Docs.
Oh, okay.
Yeah. Insert symbol. All right. So moving on. They do also call it the inner product, which great for them, but we do dot product. The problem is that you see this dot and you think that that means multiplication, and it sort of does, but it also sort of doesn't, because you're not just taking each number and multiplying it. You're then adding the pieces that you multiply. So the two x values, or the horizontal movements of your vector, and then the two vertical movements of your vector, you're going to multiply, but then add the results. So that means that you are resulting in a single number. So if you all of a sudden have a vector as your answer, then you didn't do the dot product correctly. You just need a number. And yes. And then you just didn't pay attention. All right. So again, the product of the horizontal components, which are the x parts, okay, and then the product of the vertical components, those y parts, for lack of better letters, and is going to result in a number. Super. And again, that formula is going to be given to you. And remember that that is a bold U and a bold V, because it actually means the vector that is that, and not just a point or a coordinate. Turns out that you can also have what we call orthogonal vectors. I know, huh? All right.
What does that mean?
It means that if you did the dot product, you get 0.
Well, ortho is
Bones.
teeth, bones, and birds as well.
Oh.
Teeth, bones, and
birds?
birds. Yeah.
Teeth, bones, birds.
You're right.
Okay, well, perhaps they're talking about the bird going along a vector.
If you bird teeth.
And how it's going, and how birds don't have teeth, and so it's
Some
0.
birds do. Geese have teeth.
Okay,
This is true. This is geese.
which is probably why I'm scared of them. So yeah,
Good instincts.
I'm scared of them too.
I've been chased by a goose on my bike.
My uncle Ryan was attacked by a goose and he was a child.
Yeah, see, they just sent me in. They must know my fear. I have like an internal fear.
Of geese or just
Because of apparently the one chasing me that one time. So yeah, I guess I do. Protect my babies and stuff. Okay.
No, they leave here.
So anyway, orthogonal, super duper. Okay. So turns out that we're going to find the dot product. And then that comes back to part B here, where we have that other notation, which is really just the same notation, just with an I and a J, but it's, for instance, the component form 3, -4, and 10, 9. It's just another notation. It's okay. It's kind of like how calculus was kind of discovered at the same exact time by two different people, and so they have two different notations.
That's fun.
So, yeah, there's Newton's notation and Leibniz notation.
They're the same thing though?
Yeah, but they do the same thing.
Well, I mean, you are across the world from each other.
Right.
It's bound to happen.
Yeah. So one of them decided that the derivative was going to be written like this because clearly we use functions like that, but then someone else decided it was going to be written like this.
Yeah, that makes sense.
But they mean the same thing. So,
That's kind of
anyway, so that's kind of what's happening here. There's this other form that you can write the vectors in, but it really just means the same as this component form with the bendy brackets.
They both look hard to type.
Yeah, well, especially, I mean, the ones that we had looked at actually had dots instead of a little tiny vector, so that's even more exciting there, yeah. All right.
Oh, it's an I and a J.
Yeah, it is technically an I and a J.
Oh, that's confusing.
I know. But now you can just impress everyone with knowing what it means, sort of.
I,
Kinda-
the problem
Kinda
is I don't
Don't.
know what it means.
I'm not impressed.
Oh, remember, it's a ray that ends and has an angle and a direction and a magnitude.
The only way I can think about it is how you draw a line segment. It starts one place, goes to another
But
place, and
how does
ends.
this tell us whether or not it's the dot product and whether it's orthogonal?
So we're gonna actually get the dot product by doing the math there. So remember that we're gonna take our x, or what are the horizontal movements and multiply them. And then we're gonna add that to our vertical movements after multiplying them. Same thing over here, because I'm just on a roll, so I'd multiply 3 and 10 and add it to -4 times 9. Okay. Well, you know, this is -12, and this is 14, so 2, so not orthogonal.
30 minus
And 30,
6.
and yeah, 36, so also not
Negative
orthogonal,
6.
yeah.
What? Do you
Clear
want it
math.
to be orthogonal?
No, it just says
We're just trying
tell
to
if
find
it
out
was
what
or
it is.
not. Yeah, the directions just asked us to.
Becky, I don't like this because it's easy now, and I know that means it'll get really hard later.
No, it's fine.
And it is whatever.
Orthogonal.
They're neither of them are.
If those two
It's
were
just-
zeros, but they're
Oh.
not.
They have to be zero.
Yeah,
Great.
Okay.
That I
because think of the word orthogonal and how many O's or zeros it has in it.
It has three.
Or the fact that we talked about birds not having teeth, and ortho meant teeth, bones, and birds, and how they don't. Okay.
Yeah, see, now I'm just thinking about geese, though.
I know, because they're
Geese are
scary.
zero. No,
Geese are the
0% out of
guys. Geese are the great equalizer.
All right. So this is also a super helpful moment, and I wish that I could have applied it to the geometry lesson I did recently, but I can't. So the geometry lesson that I did recently was this guy. I know, very exciting moment here. There, okay. And so the idea is that I actually wanted to find this length, because then I would know the speed. And in order to do that, it would have been really helpful if I could have taken this vector and found the angle between them. Because then I could have used the law of sines or the law of cosines. But I couldn't, so I had to do it a different way.
Do you have a right triangle in the middle of it?
I
Take out a
did.
side?
Yeah.
I cannot fathom that drawing.
Oh, well,
Oh god.
don't worry. I have little helpful moments here. Are you ready?
Kind of.
I'm going to go grab them. I have little triangles.
Wait, was this
I
for?
thought I skipped you.
This is for geometry. Yeah,
How
we-
did you not
Geometry
fathom that?
shapes are all around.
Here we
It's
go.
scary.
It's not real.
All right. So, if you make this triangle, all right, and use trig to find all of its side lengths and stuff, because we have enough information with this angle measure and this side length and trig to find all of them.
Yeah.
And then you do that with this one, because we have this side length and this angle. And so we can do that.
Uh-huh.
Then you're going to find this resulting one because this height minus this height, right, or them subtracted, is this height, right?
Oh, sure.
Yeah, and then these two lengths together makes the length of the leg.
Oh,
Yeah, and so then you get this one.
interesting.
Yeah, and then you can do the Pythagorean theorem and get the hypotenuse.
Sick.
But instead, I could have just figured out how to do the angle between them, but I didn't because
Are you withholding information from your students?
I
They
am just
weren't ready.
giving them the tools that
They're
they
too
need.
small brain.
I'm too small for it.
No, so here we go. So we are going to find the angle between two vectors by using this formula, okay?
Yeah, you
And-
he's a baby, so he drinks from boobs.
This represents the angle between them. So let's say that we've got this vector and this vector, okay? And we want to find the angle between them. That's right here. And remember that we are trying to find an angle, and we're using trig, so we're probably going to have to use an inverse, okay? Anytime that you are trying to find an angle from trig, you're probably going to throw in an inverse in there, okay? So once you do the dot product of u and v, so in our previous example, 2 was the result, okay? So that would have meant that the 2 was up here. Then we would have multiplied the magnitude and the magnitude, meaning the hypotenuse, okay? So I don't know, let's say they were 4 and 6, super. That meant that we would have 2 over 24, or 1/12, that we would do cosine inverse of to get backwards to the angle. So again, these were all just random numbers from the previous example. Yeah.
What is the magnitude? How can you get separate magnitudes?
Because the magnitude is the length of this. So since they're two different rays or vectors, then they both have two different lengths.
Is that u times v?
U times v over the absolute value.
But is it the actual u times v, or is it the fake u times v?
It's the dot product you use. Yep, because you can't do it any other way.
Wait, like, so it's like the dot,
This
it's
is-
just one number.
Dot product, yeah.
Okay, so we wouldn't actually do
But
values.
this is actual multiplication.
What?
The
Is
actual
there a
value.
fake multiplication?
Well, yes, because we're now using a dot for a dot
So we're not
product.
actually,
Got it.
yeah.
Yeah, it's because we're using
What
the
if
same
there's, like,
symbol for the same.
Made it like
That's the worst.
a
thing you can
triangle in between them or something.
Triangle in between them.
That means
I mean,
Or
you
they
can.
could just make a symbol for dot product and put it there.
do. Or not use a dot for multiplication. Use a
That's-
star symbol. I like that one.
So again, no
Yeah.
one asked us, but if they did, that's what we would have said. Okay, so and then we would have had to tell everyone who made any sort of programming that we need that symbol to be added in because it's going to happen.
Can I create a symbol for dot product?
Yes.
We could use it.
No. Because
It's a good one though.
I know, but like then no one will know what I'm talking
It might
about.
not be-
And they
it might not
already like don't sometimes, so I just like, right? Sure. I'm gonna just put this right on top of it. Go. Oh, I missed it. Okay. Anyway, what is the new symbol?
This might already exist, and if it does, then I'll amend it.
Okay. So a line with a dot that's
Well,
open.
because this is a D and this is a P.
Oh my gosh,
Oh,
that's
I
really
like
good
it.
actually. That might already be a symbol. That's pretty good. That's pretty good. Sloppy people might start to write it like that, which is a symbol. So
Yeah.
anyway.
Wait, are there dots at the end though?
It's still technically
It's
D and the P.
okay. Yeah, it is. So maybe we'll just use the symbol that already exists. Okay, it's on. But I'm also gonna write it both ways because yeah. Okay. So anyway, we're gonna find the angle between these two vectors. Super. Which means that we need to do the dot product and we need to find magnitudes of all of the things. So let's start with dot product because that's the new thing today. That means that I need to multiply the x components. So 4 and -3. Did I already do this? Maybe. And then add it to, 7 times 2. We already did this. No? -12 plus 14 is 2. Yay! So 2 is our dot product. But the formula says that you need to do the dot product and divide it by the magnitudes multiplied. So I need the magnitude of u and the magnitude of v. And how do we find the magnitude of a component form vector?
Oh, sorry. We have it.
We do have a formula, and it's very exciting.
Oh, it's like the song formula, but it's the square root of x squared minus
Plus or minus square.
x1.
Oh, well, I mean, sure, but just that guy.
Oh.
Yeah, you just take the x number and square it, and the y number and square it, and then square root all of whatever your result
So
was.
isn't that just like
Basically, distance from it. In fact, exactly.
is that not just 11, or do I not know how to do math?
16 plus 7 squared. Like you can't do 4 plus 7 first.
Oh.
Yeah.
Well, because the squared and the square root in my mind can't.
Oh no, they certainly do not.
Oh,
But that was good.
I
Yeah.
would've gotten
You did
this
a big
very
job.
wrong.
Yeah, you had too much thinking recently.
Plus 49.
So yeah, so apparently that guy is the magnitude of u.
It's pretty close.
The magnitude of v is going to be -3 squared plus 2 squared. And so 6 plus 4 is the square root of 10, which I guess I'm making a decimal. Okay, so that means that if that's the magnitude 8-ish and the magnitude of v is 3-ish, then our denominator is going to be, 21-ish, but probably not. So let's check. Especially since it's not, 24-ish. Okay. Times the square root of 65. Woohoo! So apparently it's 2 over 25.4951. But of course, 2 divided by that number is 0.0784. Super. Almost the answer, because remember we're trying to find an angle between them, so what do I have to do to that number?
Negative, no, inverse.
Cosine inverse.
That.
Inverse cosine, yeah.
Yeah, and then we
cosine.
get an angle.
Yeah,
Say,
inverse.
this is brain
So great. Yeah, brain magic. So cosine inverse of this decimal tells us that the angle between the vectors is 85.5007. Yeah. Degrees. Or whatever they told you to round to, which they didn't. So kind of a lot,
Yeah.
maybe. So you got to find the 2, right? The 2 value from doing our dot product from today. And then from the other day, from Friday, you have to figure out what the magnitude of u is, the magnitude of v is, multiply them and get your inverse. So, or you could do that thing that I did earlier. So, I mean, whatever. Find angles. Alrighty. I'm not going to do the other side of the example because I'll just leave that up to you. It's the same process. Okay. Now, this is where we even have more formulas than this. In fact, I'm going to skip this entire slide because it's annoying. And give you my other work.
Harold is sitting in a sled.
Yeah, Harold Watson. Okay.
Harold Layler.
It's not.
That's a pretty steep hill.
Yeah, well,
That is a steep hill.
It's
Damn
It's-
Harold.
hasn't been regulated by OSHA. All right. Or whoever. Hey, OSHA.
So work environments.
Sledding works environment. Okay. So we're actually going to use this moment here where work equals your weight times the cosine of your theta times the distance.
Do I have to share my weight?
Okay. No. Unless you're on a hill sledding. So, in order to get work, if you have a weight and a distance and an angle, you can multiply them all to get the work that's required for this. If you take a look at the previous slide, that was back when I didn't quite have a handle on work and was...
You taught him wrong.
No, I was just doing it in my own way, and it still worked, but it was like doing that problem when I could have just done what we did before. So it was my mind trying to wrap around it too much. So, in fact, if you ask anyone that was in pre-calc like 3 years ago, yeah, we were trying to.
I will not,
Yes, I know people who were in pre-calc 3 years ago.
Well, duh. Yeah, me too. Okay, samesies. All right, here we go. So this is our force vector, and the distance vector here is what these two are that's multiplied. This is actually supposed to be the weight, I assume, and the cosine and the distance. But again, there's magnitudes involved, and it's kind of a lot of
So we don't write that.
other symbols. Yeah, it's a lot of other symbols that we don't want to write. All right. So let's instead figure out what's happening to Harold. Okay. So Harold's
Hazel, why would you do that?
Harold's sitting on a sled on the side of a hill because apparently he's going to go down it at an incline of 30 degrees.
Hazel's like, you can't have fun. You
No
can't go
fun
sledding.
allowed.
And the combined weight of Harold and the sled is 150 pounds. So Harold's a youngin', okay? And
Good.
Hazel is holding a rope, keeping Harold at the top of the hill. Yay for Hazel, okay? So, what force is required for Hazel to keep Harold from sliding down the hill? Okay, so again, Hazel's got a rope holding Harold from going down this 70-degree slope. Because the hill's incline is 70, which means that at the top of it is, sorry, the incline is 30, which means that the top has 70 coming.
Hazel's like, you can't do this.
Hazel's
I'm
like,
with
stop
you."
it, that's my sled.
Can't do
Yeah,
it.
so.
Wait, how did you
Alright.
get the fact that, wait, I don't understand. I got the fact that the slope is something.
I'm thinking of it as a right triangle. And so they're saying,
90 degrees.
oh yeah, it is. What is,
60.
60, thank you.
Okay.
Hey,
Okay.
yeah, you're on it now, so you're back. You're back, Lex is back.
does your child?
30 plus 60 is 90 people. Okay. So either way, that is actually going to be important as we talk about the cosine of the angle. Because this angle is where, the work happens. Okay? So turns out that Hazel is not at the bottom of the hill trying to prevent Harold from going down. She's at the top of the hill. So in that case, we do actually need to use the 60 degrees versus the 30 degrees because we need the angle where the work is happening. So got to watch out for that piece. So don't put in 30 just because it said 30.
They're at. It's just like I had it wrong. I thought that she was like standing on a flat surface and Harold is off the edge at exactly a 60.
Oh, yeah, I'm going to just go with like the hill kind of continues, but not really. And she's up here and he's directly right here on his little
I
sled.
disagree.
Yeah.
This is good.
Just ignore stick people. Okay, so either way, the hill magically extends and there's Hazel. Okay.
Hazel descends from that.
She's just floating. Okay, done. The combined weight, so 150 is going to be our weight. The cosine of 60 is what's going to happen. And then this is where this formula is annoying because the distance is technically 0. Right? And so you're like, literally 0 work is happening. Okay, but that's not happening because clearly Hazel is doing something to keep Harold from going down that poor 60-degree angle, okay? So if there is no distance, then you omit it. Because work does actually happen if no one's going anywhere, okay? It's kind of like pushing your hand against your hand. I mean, as long as you're pushing, work is happening, but clearly nothing's moving, but that's okay.
Oh no.
So we're omitting our distance
If it's
in this
like
problem.
holding a 4-foot rope, would that be the distance? Because he'd be at the end of the rope.
It's more if Harold's moving.
Okay.
And and we're
Whereas
moving.
Harold is just sitting there
Yeah.
while Hazel's like, I have all the power.
If Hazel was pulling Harold towards her up in the sky, then maybe.
So right now, Hazel just has Harold's life in her hand.
Yeah.
Yeah.
So anyway, we're gonna take 150
Jesus.
and multiply by cosine of 60, and then we're gonna figure out how much work Hazel is going through here. Now, of course, work is in what, joules or something, which is like whatever. But
I literally just did this.
Okay, well,
75 work.
so yeah, exactly. Oh god, because he has half of it, right? Yeah,
Yeah.
because I'm
the only
60.
reason I know how to spell joules.
Yeah, joule.
I worked
Yeah.
is.
Oh my god.
So again,
Julie.
I
75 joules is not necessarily something that like maybe you have a huge grasp on right now of how much it'll feel like. But if you can imagine 150 pounds trying to go down a hill, like, I mean, that's what she's doing. So maybe you haven't been sledding recently.
Well, like, isn't there a thing where it's like, depending on the work done on the system or the work done by the system? So then technically, wouldn't that change where your amount of joules go?
Right, if we're talking about like where she's standing when the hill ends and things like that, then yes.
How many?
We're gonna go with basic,
Oh,
these ones, yeah.
how many funny jokes do you think it would make comparing joules to like actual joules?
Oh my god, too many. In fact, there was one earlier by Will, and I care not to repeat. Okay,
What kind of joules?
so.
I mean, not like smoking
Oh.
joules. I mean, like shiny joules.
That's right.
Yeah, no, I wasn't thinking.
My beautiful jewel.
No, my guys went to like big.
Yeah.
Yep, I know, huh?
Well, we're
Our big contaminated minds.
True, this wouldn't have been a thing like basically last year. Or 3 years ago, again, if you're talking to those pre-cal people from 3 years ago.
What was the big?
Because you guys are hanging out, yeah. Okay, so moving on. So we're gonna find the work done by pushing a 40-pound box from point 00 to 40.
Distance.
Imagine 4 feet, I guess, because you're at a certain point, you go 4 across, and now you're at 4 units away. So the work again is going to be your weight, which in this case is 40 of the box that you're pushing. Again, there's like gravity and what if it's on ice or not, but we're not going there, okay? And then technically, if we imagine what's happening, there is no angle that's there. And so you can actually just put in then cosine of no angle, because cosine of 0 is 1. So we're just multiplying by 1, technically. And then the distance in this case is 4 units, or whatever it is that they have decided each unit is worth.
You'll never.
The answer is
160 joules.
160 work.
160
I will never
joules.
not call it that.
What's the abbreviation for joules?
I thought it was
It's
like
just a J.
capital J,
Yeah.
right?
Capital J.
That's what I thought.
Big J with a little tiny S. No, don't do that. Okay. J's.
Please don't do that. That's weird.
I think I'm actually done with this example, as in like that's the last one. Nope, oh my gosh, there's a box being pushed, and then it's an assignment. Okay, so let's push another box. So now that you've kind of gone over weight times cosine of the angle times distance, let's see if you can find this next one.
But we don't know how much weight.
Push the
It's
box.
the same box from last month.
There you go.
Are you sure?
Yep,
Yes,
It says
it
the
says next to the box, the
Yeah.
box.
the box, the
So it's-
previous box. Was it?
Just from 0 forward to that.
Yeah, no, it hasn't already been pushed.
I don't
We're
know.
starting at 0, 0 again, but
I
thank you.
don't know.
Yeah, so.
This one's confusing, Meg. I don't like this one.
You have to do a triangle for this one.
Yeah,
Sick.
that's a 0 after that 4. Okay.
40.
So next you push a 40-pound box 4 feet up an inclined plane in the direction of 8, 2. How much work does that require? Which means that we might need an angle.
Time. Well,
Wouldn't you have to find the
wait.
wait?
I don't understand.
Okay.
Yes,
Okay.
we do.
You, look at this.
Do I use like law of cosines to
You
find
have-
an angle?
No, you
you
make
just
a triangle.
use a basic trick.
It says
yeah.
4 feet up.
Okay, Lex, look at this. Look at this. Direction of 8. Oh wow, 8, 4. Oh my god, crazy.
Well, if you go 4 down, then you have.
Right.
Yeah.
Oh wow, 8, 4.
And it
It almost means that you go.
So there's this like incline, but you're only going 4 of the feet of the incline.
And then go like this.
And then you'll be there with your
So
box.
this is 8,
So you need this angle measure.
4, or 2.
Do you know how to find the angle given that it was 8 across and 2 up?
No.
Yes, you do.
Lex, you know how to use basic trig?
I'm pretty
Tangents.
sure I don't
It's
actually.
tangents.
What?
What is that?
Opposite.
I actually
Opposite
don't know
side.
that.
2 is your opposite side, and 8 is your adjacent side. And so to find that angle measure,
Brains out in the loop.
it's
I
opposite.
actually
Lex
forgot
has
that
no
you could-
brain.
I legit forgot you could do that.
Hey, well there you go.
Lex,
Because it's a right triangle without being a right triangle.
It's opposite. Oh, I have
I'm sorry.
Lex has no brain.
That's like why we don't have class on ACT day, because you're pretty much done after that. All right,
It's because the
Not
scouting
just you.
system broke, right, Lex?
other people.
What?
Is it because the scouting system broke?
No, it's
Oh, I didn't do tangent inverse.
I just didn't do that.
Lex broke.
I just did tangent.
You didn't do anything?
Okay, so it turns out that the angle measure of this 40-pound box going a distance of 4 feet up this is cosine of 14.0362 degrees. So we're going to take 40 times cosine of the number we just got, and then times 4 as well. And now we know how many big capital J's are used to find what's happening here. 155.2228. So based on what we just done, which one takes more joules? Holding Harold up, pushing the box 4 feet across, or the one 4 feet up an incline?
I said 4 feet across.
That one.
The 4 feet across,
What
didn't
was
that?
the box before?
Yeah, the 4 feet across, the one that's just 4 feet, not up.
Yeah.
Yeah.
You're right.
Which, how many joules was that one?
160.
Oh, man. Okay, so 4.8 more joules of effort, which again, I have no reference for how much that is, but maybe we should get there.
Let's see.
Hey Siri,
Oh, a joule is
how many
equal,
is a joule?
a joule is equal to the work done by a force of 1 newton when its point of application moves 1 meter in the direction of action of the force.
Okay, so we need to go backwards a little bit more, because that's still not helpful.
It's equivalent to 1/3600th of a watt hour.
Mm-hmm. How about in like human, like taking an elephant and like.
Okay,
That's
so
probably.
so I asked Siri how many is a joule, and I got the response.
Diamonds?
There are an estimated 23,461 females with the given name Jewel in the U.S.
Okay, well, there you go.
So does that help?
So that doesn't help. So we'll find out about the whole jewel thing for next time.
I didn't
Um,
say.
Yeah, because that's not helpful. All right, so either way, page 519, these are the problems that we're going to do, which are going to involve a bunch of the things that we had in the previous lesson. So if for some reason you didn't do the previous lesson, you might want to start there and then move on to this guy, because otherwise a vector component form might be a little bit hard to get to. All right, so that is assignment 6-2. As a reference for the end of the block, which is coming up, like next Thursday.